Question 31. An elevator is descending with uniform acceleration. To measure the acceleration, a person in the elevator drops a coin at the moment the elevator starts. The coin is 6 feet above the floor of the elevator at the time it is dropped. The person observes that the coin strikes the floor in 1 second. Calculate from these data the acceleration of the elevator, and here acceleration due to gravity should be taken as 32 feet per second square, which is same as 9.8 meter per second square. Now, distance covered by the coin. Suppose elevator falls up to this distance. So here, the coin is 6 feet above the floor of the elevator. So this is 6 feet, and suppose this distance is x. This is the floor of the elevator. So total distance to be covered by the coin is 6 feet plus x feet. That is 6 plus x. So let the elevator has acceleration small a. Acceleration of elevator is small a. So distance covered by elevator will be half at square, because starting from west, and distance covered by the coin will be 6%, and coin is falling daily under gravity. So x plus 6 equal to half into acceleration due to gravity is 32 times t square. We put the value of x here, 1 by 2 at square plus 6 equal to 1 by 2 into 32 t square. So from here, we multiply each term by 2. So at square plus 12 equal to 32t square. Given t equal to 1 second. If we put this value here, so what do we get? A plus 12 equal to 32, or A equal to 20 feet per second square. And that is our answer. Question number 32. A ball is thrown horizontally from a point 100 meters above the ground. So we can draw the diagram. This is 100 meters, which is ground line, and ball is thrown horizontally. Ball is thrown like this, but it will follow the trajectory like this. So here, a ball is thrown horizontally from a point 100 meters above, which is 100 meters, with a speed 20 meters per second. So this is 20 meters per second. From the time it takes to reach the ground, the horizontal distance it travels before reaching the ground, and the velocity with which it strikes the ground. So we apply formula h equal to, here we are considering vertical motion and initial velocity downward is 0. So half gt square. From here we get t equal to 2h upon g square. We get the values. So t equal to 2 into h is 100 divided by, take g equal to 10. So this will become root 20 second, which is almost 4.5 second. Now horizontal range are equal to horizontal velocity into time. So horizontal velocity is given 20. Time we have got 4.5 second. So this will be 90 meters. Now we have to find out the velocity. So velocity at this point, so one component will be like this, another component will be like this. This component will be gt, this component will be, as usual, u equal to 20 meters per second. Here time is 4.5 seconds. It means this value will be equal to, say it is Vy So this will be equal to G we are taking as 10. So 10 times 4.5 seconds. So meter per second. Now we can find the resultant velocity. V resultant will be, these two are at 90 degree. So 20 square plus 45 square. This will come out to be 59 meter per second. Now we want to find out angle. The for angle, we write tan theta equal to Vy divided by Vx. Vy is GT, this is 45. So divided by 20, 5 9 is 5 4. So theta equal to tan inverse 9 by. If we evaluate it, it will be around 66.04 degree, and this can be done by using calculator. Question number 33. A ball is thrown at a speed of 40 meters per second at an angle of 60 degree with the horizontal. Find the maximum height reached and the range of the ball. So question is simple. So, ball is projected like this. This angle is given. This angle of projection. So this angle is 60 degree. And the velocity is given 40 meters per second. It will be maximum height h, and this distance will be horizontal range. So let's evaluate. Maximum height is given by u square sine square theta divided by 2. We put the values. So 40 square into sine square theta. Sine square here, theta is 60 degree. Sine square 60 degree divided by 2 into 10. So if we further evaluate, it's 1600. This will become 3 by 4. 4 divided by 2 into 10. So this will be 16 meter. Now, horizontal range R is given by u square sine 2 theta divided by 2. So 40 square into sine 2 theta means sine 120 degree, and sine 120 degree is same as sine 60 degree. Sine 120 is same as sine 60. That is root 3 by 2. So root 3 by 2 divided by just 10, value of 3. So if we simplify, it becomes 80 root 3 meter. Now, question number 34. In question number 34, in a soccer practice session, the ball is kept at the center of the field 40 yards from 10 feet high goal post. A goal is attempted by kicking the ball at a speed of 64 feet per second at an angle of 45 degree to the horizontal. Will the ball reach the goal post? So, this is goal post, and we project it like this. So we have to calculate whether it will reach the maximum height or not. This angle is given as 45 degree. So the velocity is here 64 feet per second. In this u equal to 64 feet per second. Take value of small g as 32 feet per second square. Now, we try to find out. This is This distance is given 40 yards. 40 yards means 40 into 3 feet. That is 120 feet. So let's find out the time taken by the ball to reach the goal post. So we apply formula x equal to ut plus half at square. Here, x component of velocity will be u cos 45 degree. So u is 64 into cos 45 into time is equal to, this is 120. So 64 into 1 upon root 2 into t equal to 120. So this will give t equal to 120 divided by 30 root 2. So if we simplify it, so this will give t equal to 2.65 seconds. So total time from A to B is 2.65 seconds. Now we have to find out the height reached at this time. So h is u sine theta t minus half gt square. This gives h equal to u is 64 sine theta. Sine 35 is 1 upon root 2 and time is 2.65 minus half into 32 into t square, that is 2.65 squared. If we evaluate it, it is 7.49 meter. Sorry, 7.49 feet. And this pole BC is 10 feet high in our question. So this height is only 7.49. So ball will reach up to here. It will not reach the goal post. Question number 35. A popular game in an Indian village is goli, which is played with small glass balls called golis. The goalie of one player is situated at a distance of 2 meters from the goalie of the second player. This second player has to project his goalie by keeping the thumb of the left hand at the base of his goalie, holding the goalie between his two middle fingers and making the throw. If the projected goalie hits the goalie of the first player, the second player wins. If the height from which the goalie is projected is 19.6 centimeters from the ground and the goalie is to be projected horizontally, with what speed should it be projected so that it directly hits the stationary goalie without falling on the ground earlier? So situation is simple. This is case of projectile motion. This is 19.6 centimeter. So it is projected like this. So it goes like this. Goalie of second player is here. Goalie of first player is here. This is horizontal velocity. And here it is given that this range, suppose this is AB in our question, is given as 2 meters. So we are given height and horizontal range. So let's apply the formula for height. So h equal to half gt square. So this will give 2h upon g under root equal to t. You put the values. So t equal to 2 into h. H is 19.6 centimeter, that is 0.196 meters, divided by g is 9.8 meter per second square, equal to, if we evaluate it, this will come out to be 0.2 seconds. Now, here we have to find out horizontal velocity. So distance equal to speed into time. So horizontal velocity is u and time taken is 0.2 and distance covered is 2 meters. From here we get u equal to 2 by 0.2 equal to 10 meters per second. And that is our answer. Thank you for watching.